Okay, is it the screen is visible to all?
Yes, sir.
Yes, sir.
Okay.
Yes.
The last lecture, we seen that the theorem, let K be an extension of the field F and A belongs to K be algebraic over F, then we proved that F of A, okay, the extension of F is F of A is isomorphic to F of X upon V, where V is an ideal of F of X, okay, and V is the ideal of F of X generated by the minimal polynomial for A, okay. For the example, look at here. Okay, if the f of a is isomorphic to f of x upon v, and v is ideal generated by the minimal polynomial for this element a. Okay, now example number 1. Let small I be algebraic. Okay, this is the algebraic over the set of real number. Okay, of degree what? What is the degree of I over R?
2.
2. Okay, the minimal polynomial, the minimal polynomial satisfied by a, satisfied by a, that is I, okay, over the field of real number, okay, is, what is the polynomial? F of x is equal to x square plus 1, okay, and this polynomial is belongs to capital R of x. Why? Because all the coefficients are belongs to R, set of real number. And let capital V is an ideal generated by this minimal polynomial x square plus 1. Okay, then by above theorem, what we have? By above theorem, R of I, okay, that is the extension of R, which is equal to set of Hello, am I audible?
Yes, sir.
Yes, sir.
हां,
Yes, sir.
नेटवर्क नव्हतं काय? बरोबर, वेटिंग. Okay, look at here. Let I be the algebraic element over R of degree 2. The minimal polynomial satisfied by I is x square plus 1. Okay, so here the R of I, by above theorem, R of I is equal to set of complex number which is isomorphic to R of x upon V. Okay, what is the nature of R of x upon V? P of x plus x square plus 1. So that P of x belongs to capital R of x. Okay, now look at here. This R, set of real number, is this a field of set of complex number? But set of complex number is isomorphic to R of x upon V. Okay, so from this one, we can say that this R, capital R, set of real number as a subfield of R of x upon x square plus 1. Okay, any doubt up to here?
No, sir.
Okay. आता सांगितलेलं ऐकलं का हे? If suppose this one is set A, okay, this one is set B, okay, all the elements of A are 1, 2, 3, 4, 5, 6, okay, in English letter, and in the B, 1, 2, 3, 4, sorry, 4, 5, 6, okay. The nature of the element may be different, but all the properties of set A and set B are satisfied by A and B are equal. ओके, दिसायला जरी वेगळे असतील तर हा सेट जो काही तुमचा प्रॉपर्टी सॅटिस्फाय करेल त्याच प्रॉपर्टी कोण सेट करेल? सेट बी. देन वी कॅन से दॅट ए इज आयसोमॉर्फिक टू बी. सो हियर द सी इज आयसोमॉर्फिक टू आर एफ एक्स अपॉन बी and R is the subfield of C. So we can say that this R is the subfield of R of x upon x square plus 1. Okay. So identifying, look at here. Identifying the small r belongs to capital R. म्हणजे या R मधला एलिमेंटचा नेचर कसा असेल? स्मॉल r बिलॉंग्स टू कॅपिटल R विथ याला करस्पॉन्डन्स कोण असेल तिकडे या सेट मध्ये? R प्लस x स्क्वेअर प्लस 1. Okay, so identifying R belongs to capital R with R plus x square plus 1 in the set the capital R of x divided by V. Okay, any doubt up to here?
No, sir.
Okay, now let alpha is equal to, let alpha is equal to, what is the name? Alpha, okay. Let alpha is equal to x plus x square plus 1. Okay, now compute alpha square plus 1. Okay, in capital R of x divided by V. Okay, हा एलिमेंट कशात आहे तुमचा? या सेटमध्ये. So compute alpha square plus 1 in R of x upon V. Okay, so alpha square plus 1 is equal to, this is the set. Alpha is x plus ideal generated by x square plus 1. Okay, square plus, okay, this is the square plus, okay, 1 कसा असेल तिकडे एलिमेंट? 1 कोणाला करस्पॉन्ड असेल? 1 प्लस x square
X
plus,
square plus 1.
okay, this is the alpha square plus 1 which is equal to, now this one is alpha square plus 1 चा हा असाच राहील. ओके, जो काय ऑपरेशन होणार ह्याच्यावर ऑपरेट होणार तो स्क्वेअर मल्टिप्लाय ॲडिशन. ओके, प्लस 1 प्लस एक्स स्क्वेअर प्लस 1. ओके, विच इज इक्वल टू एक्स स्क्वेअर प्लस 1 प्लस एक्स स्क्वेअर प्लस 1. ओके, सॉरी अब ब्रॅकेटमध्ये येणार. ओके, टेकिंग कॉमन एक्स स्क्वेअर प्लस 1 विच इज इक्वल टू, if a plus h is equal to h असेल तर हा a कशात जातो? a belongs to h ना, implies and implied. ओके, सो ॲडिशन ऑफ दिस टू, a म्हणजे काय तुमचं इथे? एक्स स्क्वेअर प्लस 1. ओके, प्लस h is equal to what? h. So here we get x square plus 1. Ideal generated by is x square plus 1. So this is the value of alpha square plus 1. Okay, but what is x square plus 1? This is the 0 element of capital R of x divided by ideal generated by v. So yeah, sorry, ideal generated by x square plus 1. Okay, v is the ideal generated by x square plus 1. So this is the alpha square plus 1. ओके, हा 0 कोणाला करस्पॉन्डन्स असेल आर मध्ये त्याच्या ॲडिटिव्ह एलिमेंटला. ओके, विच इज 0 इन कॅपिटल आर. Okay, so this implies alpha satisfies x square plus 1, this polynomial. Okay, so here this implies alpha is a root of x square plus 1 belongs to capital R of x. Okay, any doubt?
No, sir.
Any doubt up to here?
No, sir.
No, sir.
No, sir.
Okay, now the second example. Consider the polynomial. F of x is equal to x raised to 6 minus 2 over the field of rational number. Okay, so this implies 2 raised to 1 by 6. Okay, is 0 of small f of x. Okay, so q of 2 raised to 1 by 6, which is equal to, what is the nature of this one? A naught plus a1 2 raised to 1 by 6 plus a2 2 raised to 2 by 6. Okay, plus a3 2 raised to 3 by 6. Okay, that is 1 by 2 plus a4 2 raised to 4 by 6, that is 2 by 3. Okay, a5 2 raised to 5 by 6 and 6 by 6 घेतलं तर काय येईल 2 चे. Okay, but 2 is belongs to that set q. Okay, so there is no need to write once again, and all the ai's are belongs to q. So this is the nature of set q of 2 raised to 1 by 6. Okay, so by above theorem, this q of 2 raised to 1 by 6. Okay, this field is isomorphic to q of x divided by x raised to 6 minus 2. Okay, f of x comes out ideal generated by this polynomial x raised to 6 minus 2. Okay, so what is the nature of this one set? P of x, okay, plus x square x raised to 6 minus 2, such that this p of x belongs to capital Q of x. Okay, now let alpha is equal to x plus x raised to 6 minus 2. Okay, this is the element belongs to what? Q of x divided by x raised to 6 minus 2. Okay, now compute x raised to 6 minus 2. Okay, what is alpha? Sorry, compute alpha raised to 6 minus 2. What is the alpha? X plus x raised to 6 minus 2 bracket raised to 6 minus 2 plus x raised to 6 minus 2. Okay, so this one is x raised to 6 plus x raised to 6 minus 2. This one is minus plus x raised to 6 minus 2. Okay, now taking x raised to 2 common, so here we get x raised to 6 minus 2 in one bracket plus ideal generated by x raised to 6 minus 2. So which is equal to x raised to 6 minus 2. But what is this one? This is the 0. Wait a minute. 0, this is the 0 of q of x divided by ideal generated by x raised to 6 minus 2, which is equal to this 0 is 1 corresponds to 0 in q. Okay, so this implies alpha is equal to x plus x raised to 6 minus 2 is the root of x raised to 6 minus 2 in q of x. Okay, any doubt up to here?
No, sir.
Okay, now the next unit is splitting field. Okay, the next युनिट नंबर सेकंड आहे का पहा, मला माहिती नाही युनिट नंबर सेकंड आहे का नाही. ओके, this the next point is what is the splitting field. So chapter number 2 असेल कदाचित, युनिट नंबर 2. ओके, दिस इज द एंड ऑफ युनिट नंबर 1.
नो सर, फर्स्ट युनिट मध्येच आहे.
फर्स्ट म्हणजे युनिट मध्ये आहे का? ओके,
येस
सिलेबस
सर.
बघितलं नाही तर कंटिन्यू पॉइंट दिलेले आहेत. ओके, द नेक्स्ट पॉइंट इज splitting field. Okay, before going to the definition of splitting field, first we define what is the root of polynomials. Okay, now the definition of roots of polynomial. Okay, what is the root of polynomial? Tell me, what is the roots of polynomial?
The number which satisfies the given polynomial.
The number which satisfies the given polynomial. It's called as root of that polynomial. Okay. Let capital F be a field. Okay, let capital F be a field and the P of X be any polynomial. Okay, let F be a field and P of X be any polynomial in capital F of X. Okay, then an element, okay, small a, lying in some extension field of F, some extension field of capital F. Okay, the A is the element belongs to the extension field of some extension field of F. It's called a root of P of X if it satisfies polynomial, that is P of A is equal to what? 0. Okay, any doubt in the definition? For example, if suppose P of X is equal to x square minus 5x plus 6. Okay, what are the roots of this polynomial?
3, 2.
X is equal to 3 and 2. Is it correct? 3 to the 6 minus 3 minus 2.
Yes sir.
Okay, so x is equal to 3 or a is equal to a is equal to 3 and 2. These are the roots of this polynomial. Okay. हा p of x कशात belongs करतोय? Suppose this is belongs to r of x. Okay, so a is equal to 3 and 2 also belongs to capital R, which is the R is the extension of x. Is it correct? R is the extension of R. Okay, असू शकतो की any field is extension of itself. Okay, और असंही लिहू शकतो और सी हे दोन कॉम्प्लेक्स नंबर आहेत की येस okay so here the 3 and 2 are the roots of this polynomial okay any doubt up to here
No, sir.
okay wait a minute now the definition of multiple roots so the next definition is multiple root let capital F be any field. Capital F is any field and P of x with the polynomial belongs to this capital F of x. एकदा एक symbol आपण K का सोडतो. Okay, F of x. If capital K is an extension of F, then extension of the field F. Okay, then A belongs to capital K is said to be a root of P of x of the multiplicity m. Okay, multiplicity small m. If in K of x, okay, important, okay, in K of x, we have x minus a bracket raised to m, okay, is divisor of P of x, okay, whereas x minus a bracket raised to m plus 1 is not a divisor of P of x. Okay. Any doubt in the definition of multiple roots? Okay. What happens if x minus a bracket raised to m plus 1 is the divisor of P of x? काय होईल जर x minus a bracket raised to m plus 1 जर हा जर डिवायझर झाला तर काय होईल
Multiplicity m plus 1 will.
multiplicity m plus 1 होईल. Okay. Hence, x minus a bracket raised to m plus 1 is the not the divisor of P of x. Okay. Now, a root of multiplicity 1, root of multiplicity 1 is called a simple root. So, एकदाच असेल m is equal to 1 असेल तर त्याला काय म्हणायचं simple root and a root of multiplicity greater than 1 greater than 1 okay it's called multiple root okay any doubt
No, sir.
ओके एकदम सोपे सोपे डेफिनेशन आहेत हे 9वी 10वीला झालेलं आहे डेफिनेशन आहे ओके पॉलिनॉमियल त्याचे रूट्स काढा ओके 9th 10th स्टँडर्डला झालेलं आहे ते सगळ्याचे ओके नाव द नेक्स्ट थेरम इज जो सोपा भाग आहे त्याला जास्त वेळ द्यायला नको आपण ओके नाव द नेक्स्ट पॉइंट इज रिमाइंडर थेरम रिमाइंडर थेरम okay look at the statement if P of x belongs to capital F of x, and if capital K is an extension of capital F, then prove that for any element C belongs to capital K, P of x is equal to x minus C into Q of x plus P of C. Okay, where Q of x belongs to capital K of x, and the degree of Q of x is equal to degree of P of x minus, Vidya said,
1.
1. Okay, this is the remainder theorem. If P of x belongs to capital F of x and K be an extension of the field F, then prove that for any element C belongs to K, P of x is equal to x minus C into Q of x plus P of C. P of C तुमचा काय असेल? Constant element असेल. And where Q of x belongs to capital K of x and degree of Q of x is equal to degree of P of x minus 1. Okay, look at the proof now. We have F is the extension of, sorry, K is the extension of F. It means F is contained in K. This implies capital F of x is contained in capital K of x. Okay, so this implies if P of x belongs to capital F of x, this implies P of x belongs to, but F of x is contained in K of x. So this P of x is contained in element of K of x. Okay. Now this P of x belongs to capital K of x. Now the polynomial P of x and x minus c are both in K of x. Is it correct statement? The polynomial P of x and capital X, sorry, x minus c. Okay, is it the x minus c belongs to K of x? X minus c belongs to capital K of x. Why? Because c is the any element of K. Minus c is also element of K, and the coefficient 1 is the also belongs to K. Okay, since K is the field, hence the x minus c is also belongs to K of x. Okay, any doubt up to here?
No,
No,
sir.
sir.
Okay, give here the reason. What is the reason? X minus c belongs to capital K of x, since 1 and c are belongs to K. Okay, the c belongs to K. Now, therefore, by division algorithm, there exists a polynomial q of x and r of x in capital K of x such that okay, P of x and x minus c, these are the elements are in K of x. Okay, so by the division algorithm we can write this P of x is equal to x minus c. Okay, divide this P of x by x minus c, so we get x minus c into Q of x. Okay, quotient plus the remainder r of x, where the degree of r of x is less than degree of
of x.
P of x नाही, x minus c. ओके, एखाद्या पॉलिनॉमियलला जर p of x असेल, इकडे जर x minus c ने डिवाइड केलं तर असेल, हा इथं काहीतरी q of x येईल आणि शेवटी रिमाइंडर काय येईल तुमचा?
1.
हा, कॉन्स्टंट असेल काहीतरी. ओके, कॉन्स्टंट टर्म येईल. त्याची डिग्री किती असणार? 0 असणार. ओके, जर 1 डिग्रीचा असेल, तो जर खालचा जर रिमाइंडर त्याला डिवाइड केलेला ना पुन्हा. ओके. So we have p of x is equal to x minus c into q of x plus r of x. It is volatile. Okay, where degree of x, r of x is less than this one. Okay, r of x. Where the degree of r of x is less than degree of x minus c. Okay. Now here the degree of x minus c is equal to 1. Okay. Hence either r of x is equal to 0 polynomial or degree of r of x is less than degree of x minus c. Is it correct? Okay. So this implies either r of x is equal to 0 or degree of r of x, okay, is equal to 0. Which degree किती आहे? 1. Okay, the degree of r of x is less than 1, it means degree of r of x is 0. Okay, so thus r of x is a constant polynomial. Is it correct?
Yes, sir.
Okay, constant polynomial in capital K of x. Okay, that is r of x is equal to, let that constant is r in K. Say, okay, let that constant polynomial r of x is nothing but r. Okay, so thus we have p of x is equal to x minus c into q of r plus r. Okay, so putting x is equal to c. Okay, so we get p of c is equal to 0 into q of, sorry, q of x, q of c, okay, plus r. Okay, so this implies p of c is equal to r. Okay, so therefore p of x is equal to x minus c into q of x plus, what is the value of r is? P of c. Okay, give it as an equation number 1. Okay, so we proved that the p of x is equal to this one. Okay, p of x is equal to x minus c into q of x plus p of c. Okay, now we have to show that degree of q of x is equal to degree of p of x minus 1. Okay, now suppose the degree of p of x is equal to n and the degree of q of x is equal to m. Okay, now from the equation number 1, also the degree of polynomial on the right hand side of equation number 1. Okay, right hand side of the equation number 1, this one. Okay, is the degree of
Then
polynomial on the right hand side of the equation 1 is m, this one is m. And what is the degree of this one is 1. So this is 1. So this one is m plus 1. Okay. By the definition of equality of two polynomials. Okay, these two polynomials are what? Equal, na? This one and this one whole. But hence the degree of the left hand side and right hand side must be equal. Okay, so by the definition of equality of two polynomials, we have we must have this one, degree of p of x is n, is equal to, this is 1, this one is 1, and this one is m. This implies m is equal to n minus 1. Okay, so this implies the degree of q of x. What is m? Degree of q of x. N is degree of p of x. Okay, minus 1. Hence the proof. Any doubt?
No, sir.
काय हार्ड नाही आहे. डिव्हिजन अल्गोरिदम इथे यूज केला. ओके. Any doubt in this theorem?
No, no, sir.
Okay. Now the next corollary is there, factor theorem. Okay, what is the statement? Okay. Statement. If small a belongs to capital K, okay, it's a root of p of x belongs to capital F of x. Okay, where f is what? Extension of f is the subfield of k. K is the extension of f. Okay, where f is contained in k. Okay, so no need to write it. Okay, then in capital K of x, prove that x minus a divides p of x. आता काय अवघड आहे बाबा या थेरममध्ये, जर रूट असेल तर एक फॅक्टर एक्स मायनस ए फॅक्टर निघतोच त्यात. ओके, हे सगळे थेरम सोपे आहेत, एवढे हार्ड नाही येते. इफ a belongs to k is the root of p of x, then x minus a is the factor, hence x minus a is divisor of p of x. Okay, here's what the proof guys. So right now, let p of x belongs to capital F of x, and let a belongs to capital K, where capital K is an extension of F. Okay, extension of the field F. So by the remainder theorem, okay, by the above theorem, we have in capital K of x, p of x is equal to x minus a. Okay, you add that x minus a by to p of x. So what we get? Q of x plus p of a. Is it correct?
Yes, sir.
Where q of x belongs to k of x. Okay, where q of x belongs to capital K of x. Okay, so therefore p of x is equal to x minus a into q of x. What is the value of p of a is? 0. Okay, so therefore p of x is equal to x minus a into q of x. Therefore, in capital K of x, okay, what it implies, x minus a is a divisor of p of x. Okay, so this implies x minus a divides p of x in capital K of x. Okay, any doubt?
No, sir.
Okay, so we will see the next theorem on this statement. Okay, the proof of the theorem is very lengthy, so we will see on the next lecture. Okay, write down the next theorem. Okay, so this is theorem. The polynomial of degree n over a field f, over a field can have at most how many roots? एखाद्या पॉलिनॉमियलची डिग्री जर n असेल over the field
n.
at most n roots. Okay,
N.
at n roots in any extension field. Okay, suppose x square plus 1 belongs to capital, suppose R of x, set of real number R whole number. Okay, याला किती रूट्स असतील?
2.
At most 2 on any extension of field R. Okay, what is the extension of R? C, set of complex number. Okay, belongs to 2 रूट्स असतील या पॉलिनॉमियल. ओके, आता हे माहितीच आहे सगळं आपल्याला, म्हणून तरी आपण प्रूव्ह करतो टीचर्स. ओके, त्यामुळे हे जे पार्ट इझी पार्ट आहे त्याला आपण जास्त वेळ नको घालायला. तुम्हाला वाटत असेल खूप स्पीड चालेल. ओके, एनी डाऊट अप टू हिअर?
No, sir. No, sir.
No, sir.
ओके, काही अडचण असेल तर विचारू शकतो, ते आपण थांबूया. ओके, या सॅटर्डे पासून सेमिनार पण आहेत, तर सेमिनारच्या बाबतीत कोणाला काही अडचण असेल तर तेही विचारू शकतात.